Hey class, this is Mr. Sutton. I would like to start this video off by apologizing that I could not be there for you for your first day of school, but I'm very excited to meet you all, and I hope this video makes up for it a little bit. So let's talk about what we're going to do today. So the bell work, there's the 1.1 handout that you should have gotten. You want to complete up to the stop sign. I believe the bell work goes a little bit onto the second page. So you want to complete up to the stop sign. You may work in groups at your table only, not at the other tables. Make sure you're talking softly when you're working with them, and make sure you're not getting too loud. And the other thing you will need to complete the bell work is on Google Classroom. You should see this Desmos activity, turtle crossing. So you want to open that. So then continue to the activity. So it should look something like this, and you want to sketch a graph and then watch how that graph displays what the turtle is doing. There's a lot of different ways you can draw your graph, which will change what the turtle does. So you want to make some connections between what the graph is doing and what the turtle is doing. That's kind of the idea for the bell work. So go ahead and work on the bell work. Do as much as you can, and then and pause this video, and then when you are finished, continue the video, and I will be back and I will continue explaining some of the things on the bell work. So go ahead and pause the video now and work on the bell work. Okay, so hopefully you have completed as much as you can of that part. If you weren't able to get all of it, that's totally fine. We're going to go through it all now together. So the blue text here is the text that hopefully I was expecting you to get, but again, if you didn't get it, that's fine. You can get it down now. The red text is more stuff that you want to add in the margins that maybe you weren't necessarily going to get on your first try. So on slide 1, draw a distance versus time graph to represent a turtle's journey crossing the sand, then press play on the animation to see what happens. What did you notice? What do you wonder? So you should have noticed that when you draw a horizontal line, the turtle doesn't move at all. It's staying in the same position. And when you notice or when you draw a steeper line, he goes faster. When you draw a less steep line, he's going slower. So I wonder what the equation is for my graph. So here, distance is a function of time, right? So that is why the distance is affecting the speed at which the turtle is moving. So copy Luca's graph on the coordinate shown, the finish on the coordinate grid shown, then finish the story to describe the turtle's journey based off the graph. So you want to copy this into your turtle thing. So that's what you should have done in the turtle crossing game. And then you should have noticed that the turtle moved away from the water at a constant rate. Then he didn't move for 2 seconds. Then the turtle moved away from the water at a constant rate again until just over 4 seconds. Then he stayed still. So how far away from the water was the turtle after 8 seconds? 10 feet. So this is what that looks like in function notation. D of 8 equals 10. So after 8 seconds, 8 is being plugged into the function. And then the distance then is 10 feet. At what time was the turtle 4 feet away from the water? How do you know? After 5 seconds, because the y value when the time is 5 seconds is 4 feet. So the function notation of that would look like this. D of t equals 4. And then when you solve for t, you should get t is 5. Looking at the graph is how we would solve that. At what time was the turtle 12 feet away from the water? How do you know? Never, the graph never reaches 12 feet. So this is the function notation again. The range of d of t is from 0 to 11. So that is the range we're dealing with in terms of our y values. Arnav's distance versus time graph is shown below. Does this graph represent a possible journey for the turtle? Why or why not? No, the turtle cannot be in 2 locations at once. So assuming that we have just one turtle, this would not work. But I believe the turtle crossing game does let you do this. Let's see. I think we can draw a circle, and it will split our turtle into two, like something like that, right? So you'll notice, yeah, once we get here, yep, now we have two turtles. And then go back to one. So it is possible to do that in this game, but it does create multiple turtles, which is what we are not looking for. So each input can only have one output. That is a rule of functions. So think about the number of turtles that you have. So is it possible for the turtle to be 5 feet away from the water at multiple points in his journey? Yes, he could have moved backwards and forwards and passed each location multiple times on the journey. So repeated outputs are always allowed. All right, so quick notes here. The next section, here's a place where we can summarize some of the stuff we talked about. So a function is a relationship between two variables. One variable determines the other. So this is function notation. This is where we name our function just in front. So a lot of times the function will just be called f. That's kind of the first generic name for a function that you learn. And then we have the independent variable. This is the input. Usually x is denoted for that. And then the dependent variable, the output, is usually denoted as y. You might see t a lot for the independent variable. Usually time is our independent variable when that is being used. So x or t are pretty common there. Each input can only have one output. To evaluate a function means to find the output for a given input by plugging the input into the function expression. So to clarify here, each input can only have one output. So like if the input is 3, then that means the output has to be just one value. Maybe it's 6, but it can't be 6 and 7. That's the case where we would have multiple turtles. If you remember the vertical line test, that's the case where it would fail a vertical line test. But you're allowed to have repeated outputs. You can have, so the input 4 can give you 6, while the input 5 also gives you 6. That's okay. I can show you this in the turtle crossing game. So here, if you have like a U shape, we have repeated outputs like 4. It looks like 4 is an output for 2. And 4 is also an output for 10. This is okay. If I press play here, the turtle will never duplicate. We always just have one turtle here. So this is a function for sure. Right? But if we make this shape on its side, now we have something that fails the vertical line test. This 8 has 2 different outputs. It has an output here right around 2 and one right around 10. So this will fail. We'll see there's going to be 2 turtles. Yep. So this fails. This is not a function. It is a graph, but it's not a function. So that is the difference there. So now I'd like for you to try to check your understanding on the next part of the packet. Go ahead and pause the video and try that. And then I will display the answers on the video so you can check to see how you did in just a moment. So pause the video now and work on the check for understanding. Okay, so hopefully you were able to complete some of those. If not, hopefully you have an idea of what you need to work on here. So determine, I don't want to read all of these because I don't think I'll have enough time in the video. But go ahead and pause the video, check your answers for these. Here, this is supposed to be you're inputting a smiley face into the function, so it's smiley face squared. It's just kind of giving you the idea that anything could be the variable. It doesn't have to be a letter of an alphabet necessarily. Here we can see this is failing the vertical line test, so this is not a function, right? So 0 has 2 outputs, so that would fail. There's 2 turtles going on here. And here are some more answers. Is that it? So make sure you're checking these, correcting these on your paper. Make sure you correct them so you don't leave yourself with incorrect notes. And then once you have these down correctly, make sure this is, yeah, that's the end. So your IP should be the next page already stapled on the packet. And so that is what you need to work on for the rest of the class. And that is due before class on Tuesday, the next time I see you. And I will be back on Tuesday, hopefully. So I will see you then. So bye. Oh, wait, no, actually, sorry, not Tuesday because this is for the A day kids, right? So, because Friday is an A day, that's the day I'm not going to be here. So this will be due Monday, and I will not be back on Monday. Monday I still will not be here, so you'll get another video from me on Monday. Unfortunately, yeah. So on A day, yeah. So I will see you next Wednesday is the first time I will see you, and I'm very excited to meet you all. So have a good day, good luck in your IP, and I'll see you Wednesday.